Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In this section, we shall define various type of load, primary load and the load combination made of these primary loads and how to apply these primary loads to the structural model. The primary loads are the gravity load, the seismic load, the wind load. The gravity loads are mainly dead loads, all dead load, floor dead load, live load or imposed load. Seismic loads are static seismic load, dynamic seismic load. Dynamic seismic load could be derived either from response spectrum method or time history method. But in routine design, usually response spectrum method is followed. Now we have to know the reason uh, of one recommendation by the court. The court says that base shear obtained from the dynamic analysis must be scaled up to match with the base shear that has been obtained from static analysis. The reason is being that in dynamic analysis, the base shear is obtained from rigorous mathematical analysis by the software as per the stiffness of the bare frame. So the time period calculated by the software is as per the stiffness of the bare frame. But in static analysis, the time period is calculated based on the empirical formula derived from various experiments and seismic records obtained from actual buildings. So actual buildings are not a bare frame. They consist of walls, various type of fittings, etc., which actually increases the stiffness of the building. So this non-structural material do not know that they are not structural. So obviously, whenever there is a seismic occurrence, they also take part in resisting load with structural members. So actual earthquake force is much more than what is obtained from dynamic analysis. So this is the reason the court says that the base shear obtained from dynamic analysis must be scaled up to match with static analysis. Then come the wind cases. There, the wind could be from various degree. The degree of incidence could be 0, 180 degree, 90 degree, 270 degree. And there will be one set of wind with positive internal pressure and one set of with negative internal pressure. So altogether there will be 8 cases of wind which will constitute primary wind load cases. Now next is making group. We should make some floor group as per area and geometrical group as per function that will help us in loading the structure as well as during optimization of the structure or during assignment of design parameter to the various structural members. We could also define some dummy members. Dummy members can be assigned with zero density. They are usually sometimes defined to carry to transfer wall. We can create some dummy members to transfer wall to the structural, to transfer load to the structural members. So in this hypothetical building, we do not have such wall which are going to be not aligned with the walls. We have only periphery wall. Then come how do we number the loading in STAAD Pro. So we should follow a pattern. This will actually help. Usually we may start with gravity load cases or load combination with 51. load combinations, dynamic load cases with 101, with static load cases with 201, with wind load cases 301. Similarly, for primary load cases also, static seismic load could be 1, 2, 3, and 4. The dynamic would be 5, 6, 7, and 8, 9. And then we can go for gravity load, that could be 11, 12, 13. Then we can go for primary wind load, that could be 21, 22, and so on. So we are leaving a gap in between the load number, so that in case we at some time we come to know some other load are to be incorporated. So it can be incorporated according to the grouping. Maybe within the group of the gravity load, maybe within the group it could be recorded in the group of wind load or group of seismic load. So in such a case, if we do not maintain gap between the types of load, maintain gap between the numbering of the types of load, we may have to renumber all the loads all together in the STAAD, which will be very time consuming. So our load numbering should be such that whenever a new loading type is required which belongs to a certain group, we can insert in that group easily. Now we shall open the STAAD model, and we'll make group according to the geometry of similar members or similar functions of structural members. So that could be column, fixed main beam, prop main beams, and so on. So let us open the STAAD model. The STAAD model is open now. Go to tool, create new group, select geometry from the drop down and create a group named columns. Okay. Now your dialog box appears. So we have column, then create a group, geometry, main, fixed beams, then geometry, main, simple beams. This is again geometry. We have to maintain certain amount of alphabet within that. So we can say main, sim beam. This will be main simple beam. Then create geometry, secondary simple beam, so sim beam. Okay. Then create joist, similarly all other groups are created. We have all the groups, geometrical groups name defined now. We have column, main beam, main fixed beam, main simple beam, secondary simple beam, joist, stringer, cantilever, raptor, strut ties, group basing, and vertical bracing. So let us assign this group one by one. Let us go to column, select column, then select all the columns. Making a group actually helps you a lot when you have a very big structure or big complex geometry. This is a simple structure, so this type of small model might not require making of group. But I'll always advise you to make a group. It will always give you a better control on the model. So associate to selected geometry, associate. Yes. Post-processing result will be lost. Let it be lost. We do not need it now. We have already checked the model. Yes, okay. Now we select main fixed beam. Then select the main girders. These are the fixed beams. We can actually cut a section along the mezzanine floor and select this when big model is there, but in this small model we can directly select it. So let us associate it. In a similar manner, all the other 9 group is assigned. We select main simple beam, associate with the selected geometry, associate. These are joist, the selected one are joist. Associate. Then for a stringer, we can go to property, select by property, property name, select ISMC 250. Okay, associate. Then we have the secondary simple beam. These are secondary simple beam. The beam supporting the stringer at floor level. Associate. Then we select joist. Now for this we can go to specification, select by property name. We had assigned ISMB 200 for all the joists, so we can select them and associate this member to the joist. Then we select stringer. Then again go to property, select by property, by specification property name, ISMC 250. These are the stringer, associate them. Then comes the cantilever part. The rafters have the cantilevers, so we select all the cantilevers. Associate. Then we have the rafters. These are the rafters. This could be selected by selecting by property name as well. Associate. Then we have strut and ties. Let us see which are strut and ties. Go to property, select by property, specification by property name. Yes, these are strut and ties. These are also strut and ties. This is also strut and ties. So associate. Then we have roof braces. Select by property. These are roof braces. Associate. Vertical braces is naming. Select by specification property name. Vertical basing is also assigned grouped. Now one group is left. We have a landing beam for the stair. When there is a multi-story building, there could be a lot of landing beams. So we should also create a group for the landing beam as well. So land beams. Okay. So now we have 12 numbers of group. So we have this as a landing beam. Let us try to select it. Press Shift K. The nodes will be seen. So let us try to select this landing beam through by property, by specification, property name. ISMB 350 was the landing beam. So this has been selected. Now associate it. So our geometry is now assigned with various group. Now we shall create floor group, we have only one functional use here, that is office uses. If there could be other functional uses, say some lobby, something like that, corridor, there could be that kind of floor group. But we here in this case, we have only office uses. So we need to cut a section along the mezzanine. Okay. So this is the node number 11. So go to tool, cut section, exit plane 11. Go to top view. Select these members as I have selected. So we can actually deselect these members. Every area should follow a closed rectangular type of area or polygonal type of area, so that STAAD can generate the loads. So now we shall create a floor group, floor, office. Okay. Associate to the selected geometry. It is associated now. Next is we shall assign the gravity load at the mezzanine, also at the roof level. So we have already calculated gravity load. We had a discussion about these loadings, computation of loading in previous section. So let us go back to the sections, part of that section once more. So we have dead floor load as 5 kN per square meter, staircase waste slab load as 4.6 kN per square. Then wall running load 2 kN per meter and 2.17 kN per meter. Wall cladding load 15 kg per square meter. Roof sheeting load 45 kg per square meter or 0.45. Now let us go to general loading, dead load. We already have assigned self weight. Now we have to assign floor dead load. That is weight of deck slab. We had calculated this as a 5 kN per meter square. Click on dead floor load, click on add, then select floor load minus 5 kN per square meter, click group ready button. Here deck slab load shall always have honor distribution. So check this box, select office, then click add. Close the add new load items dialog box. So this office load is now generated. You can see this office generated load. Now to change the scale of this display, we can go right click and go to change the scale of distribution forces. Let's say make it 5. So it has got reduced. Now go to view whole structure. We have to assign dead load of the waste slab to the stinger. As per the cutout provided in the architectural drawing, the stinger seems to be of the size of waste slab width seems to be size having 1.2 meter width. So our waste slab weight we had calculated is 4.6 kN per square meter. So 4.6 into 1.2 divided by 2 is equal to ox output 2.776 kN per meter. So we shall assign this load to the stinger. Now select dead floor load, click on add. Now select member load and add new load items. Add 2.76 minus 2.76 global GUI direction. Add. Select this load. Go to select. By specification property name, we know the stingers are of ISMC 250. Select this 250. Select this 2.76 kN per meter load again and check radio button assign to selected beam. Then click on assign. Now you can see the load has been assigned to the model. Now we have to assign dead load of the roof sheeting and wall cladding as well. So our bay to bay spacing is 4 meter, 4 meter, 4 meter, and along the gable end it is 6 meter. So we had calculated the weight of the roof sheeting as 45 kg per meter square, that is 0.45 kilonewton per meter square. So this load would be carried by the gable raptor as per their tributary width. So this gable raptor has a tributary width of 2 meter. This is 4 by 2 is equal to 2 meter. This interior raptor has a tributary width of 4 meter. So this will carry a load 2 into 0.45 is equal to 0.9 kilonewton per meter. And the interior raptor, they will carry 4 into 0.45, that is equal to 1.8 kilonewton per meter. Now let us add this load to the dead load, dead floor load. So select dead floor load, add member load, minus 0.9 kilonewton meter, then minus 1.8 kilonewton per meter. So select 0.9. Go to select by group name. Cantilever, and raptor. View, deselect all the members, go to top view, remove node to node distance, shift K will show the node. Select the gable raptor, select 0.9, assign to selected beam, assigned. Select 1.8 kilonewton per meter, select interior raptor, assign. Go to isometric view to see if the load has been assigned. Okay. Now go to view whole structure. Now you see we have to add the cladding load. We had calculated cladding load is 15 kg per square meter, that is 0.15 kilonewton per square meter. So this column has a tributary area of 2 meter. The interior column along Z direction has a tributary area of 4 meter. The gavel column has a tributary area of around 6 meter. That is, this is equal to 6 divided by 2. This is equal to 6 divided by 2. So 6 meter. And this corner column will have a tributary area of 2 meter from this direction. This is only for wall cladding load, and from this direction 3 meter. So we have for interior column Z direction, tributary area is 4 meter. For this 4 meter, for this we have 5 meter of tributary area, and for this we have 6 meter of tributary area. So 4 into 0.15, 5 meter into 0.15, 6 meter into 0.15. So this works out to be 0.6 kilonewton per meter, 0.75 kilonewton per meter, and 0.9 kilonewton per meter. So let us add this load to the load number 11. Select this load, add member load. Minus 0.6 kilonewton per meter, add minus 0.75 kilonewton per meter, add minus 0.9 kilonewton per meter, add. So these columns have cladding load of 6 kilonewton per meter in global Y direction. Then the corner column has 0.75 kilonewton per meter of cladding load. Then the gavel column has 0.9 kilonewton per meter. Then our next load case is wall dead load. We had calculated wall dead load as 2 kilonewton per meter and 2.17 kilonewton per meter. So let us cut a section through the mezzanine again. The mezzanine mezzanine has the provision of dry wall. Tool cut section, cut through exit plane 11. Go to top view. Now add, click on wall load number 12, that is wall load. Add member load minus 2 kilonewton per meter. This will be along Z direction, and then minus 2.17 kilonewton per meter. Add, this will be along X direction because the wall height is varying here, so we are having a greater weight of wall on the average. So select 2, click on beam cursor, select the beam that will carry this wall, carry the wall load along Z direction. Click assign. Then select 2.17 kilonewton per meter. Select the members that will along x direction that will carry the wall load. Assign. So the wall load has been assigned. We can see in the isometric view. So let us save it. So now let us open the STAAD editor. We'll assign the leave load through the STAAD editor itself, because that makes the process faster. Scroll down to load case 11. Copy this load. Copy the dead load under load 11. Paste it below load 14, load live load. Cell pointer will not be there in the live load. So delete this part, select and delete this part. We know office load, live load is 4 kN per meter square. So change this 5 to 4. Then the staircase will be having 4 kN per meter. So 4 into 1.2 divided by 2. Or it's got to be 2.4. So change this 2.76 to 2.4. Our slope is 1:10. So it will carry 0.75 kg per square meter. So tributary width of gable raptor is 2 meters. So 2 into 0.75 is equal to 1.5. So change this 0.9 to 1.5. Then interior 0.75, tributary width is 4 meter for interior raptor. So change this to 3. Obviously, in girts, in the wall cladding, there will be no live load. So we delete it. So we save the editor, close it, and check in the graphical user interface if the live load has been assigned properly or not. Probably the dead flow load has been copied again, so we have to open the editor again. Let us go and see what has happened. Just see, under load 14, load 11 has been also better. So this load is already defined above, so we cannot repeat it. Obviously, this would have created problem during run analysis of a STAAD. So delete it. Save it once again now. Now let us see the graphical user interface, what is happening if the live load has been. Now the live load has been assigned properly. Office has been assigned 4 kN per meter. The staircase has been assigned 2.4 kN per meter, and gable raptor 1.5 kN per meter, interior raptor 3 kN per meter. With this, our gravity load assignment is complete. In next section, we shall discuss on assignment of seismic load. Till then, see you.